Hi class, welcome back. And this is our last portion of the exam 3 review. We're going to cover another 4 problems in this video. I hope you get a chance to review some of the previous videos and can start to review the exams. And hope this last one we will wrap it up here, all right? Okay, so the first problem we're going to take a look is number 13. So the number 13, they tell you, is that a raffle offers the first prize is $500, the second prize is $70, but with 3 second prizes here. You're going to spend $2 per ticket, and then this, the total there are 500 tickets are sold. So you decided to buy a ticket. What do you expect the payback? Okay, so let's take a look here, right? So the first thing here is, so let's create a, okay, so let's create a little tables here, and these tables here. Okay, so in here, this is my X value. That is how much I'm going to expect, to gain here, right? So I expect I can get $500, or I can get how much? I can get $75. And what is the probability I can get here? So that I only sell 1 ticket, right? So this is 1/500. Then they sold 3 tickets here. So how much I can get here? I can get 3 tickets, so it's 3 out of 500 here. Then how much I expect to win? Okay, so the expect to win here. That means I expect to win the $500, but I'll only have 100 over 500 chance. So I have $75 and the times 300 or 3 over 500. That's easily expect the value of I'm going to win some things, right? So this is once here, you get is what I think I calculated. This is $1.42. So you expect the win or the payback is $1.42, but you pay, right? So you pay $2. You pay the $2 to place here, correct? So you pay $2 to play. So really, this is not a fair game here, because you really expect to what? You expect to lose how much? You expect to lose the 0.80 so you really expect to lose 58 cents here, right? So you're going to expect to lose the 58 cents. So this is not a fair game. And fair game, that means what is the expected payback. So what do you expect to win and how much you pay out. So should be what? Should be the same here, right? So you expect to get $1.42, but you pay $2 to play. So that's why you expect you have a loss. It's 58 cents. So that's why we say this is what? This is not a fair game here. Okay? Okay, so now let's take a look at our next problem here. So the next problem is number 14. So the number 14, this is the binomial distribution. That's what we cover in the section 8.4. So let's see the number 14. we talk about number 8 here. It said we have a EMA test, right? So the the probability, so that in general accept that in unrelated people. So I do a probability, like if unrelated, but this test will accept is 1 in 5, right? So 1 in 5 people will be accepted even they is unrelated. That means your probability to get accepted is the 0.2, 1 in the 5 people, right? Okay, so now the first part here, they say if 6 bands are compared, right? So you have 6 bands are compared, and then what is the probability you will get exactly the 3 bands will match? That means your x equal to what? X equal to 3, right? So you are looking for the probability of x equal to 3. Because this is equal, so now I know I need to use the what? I need to use the TI calculator. We call this the binomial PDF here. Okay, so let me switch to the TI calculator, and then we can take a look here. Okay, so in here, this is what kind of review what we did, right? So first things here, you said second distribution. Then you go down here, this kind of review we did 8.4. So you find that this is a binomial, BINO, and PDF. So you put an enter. So how many trials here? I have 6 bands. The probability is 0.2. So what is the X value? I'm looking for exactly the 3 bands match, right? So now you will get is a 0.08192. Okay, so let's go back to the whiteboard. Okay, so the whiteboard's here. Okay, so let me see. Okay, so how do I get a pointer? 08192. Okay, now let's take a look at the part B here. The part B here, if 6 bands are compared in the unrelated people, so your N still is 6, right? And what is the probability? No more than 3. No more than 3. That means what? No more than 3. That means X has to be what? It's less than or equal to 3. That's right. So we know this is less than or equal to 3. So I can use a TI calculator. We use the binomial CDF. Right? So CDF, if you still remember the C, that means the cumulative, right? That means add all the way up to 3. And so now let's take a look. What is the value? Let's try to do one more time. So let me switch to my calculator. Okay, so now the same way you do the second distributions, then you go down to where? You go down to the CDF, right? So you still have 6 trials. You still have a 0.2. Now the CDF, you still is 3 because it's less than or equal to 3. Then here you will get this is 98304, right? So that's why no more than 3, right? So no more than 3, that means less than or equal to 3. Okay, let me go back to the my whiteboard again. Okay, so that's why we say it's no more than 3. So that's why you go use the CDF. So that's why basically I'm looking for is here. So this is a probability. X is less than or equal to 3. So you use the calculator. It will give you 0.98304. Okay, so now let's take a look at part C here. Part C here say if 6 bands are compared, what probabilities at least 1 will match, right? At least 1, that means we talk about the probability at least 1. We use these tricks many times. At least 1, That means it could be 1, could be 2, could be 3, could be 4. So you can add up all this, or like we talk about, we said the tricks here is we say 1 minus probability none. Remember this? We have used this method many times. If I want to find out this one, to simplify the calculation, I'm finding the probability none. So that means I'm using 1 minus, right? So I'm set 1 minus the probability, x equal to what? X equal to 0s here. So now, because this is just equal sign, so you can go, I'm not going to switch back and forth anymore. I assume you know how to use the TI-84 now. So you can use the TI-84 and you can use the binomial PDF, right? Because it's equal sign. So that's why you use the PDFs here. So now I assume we find the, you go ahead and put the number. So this will be 0.2621. And then you minus this will be 0.7379. Okay, so remember these tricks, right? So if it's at this one, and to simplify the calculation, we can use the 1 minus nones here. Okay, the last one is really very interesting. Let's say that if you were decided a paternity test, and out of the 21 bands of your DNA, you find a 17 match. So based on this result, will you believe that the person being tested was the father? Okay, so this one is really interesting here. So let's see here. So we said, okay, probability, right now I have, 21 bands, right? So the 21 bands, and I'm looking for x is equal to the 17th here, okay? And then you will find the probabilities here. That means you will use the probability x equal to 17, then you use the TI calculator again. So the TI calculator, it will be showing you, so this one's here, so this will be 3.213 to the e to the negative 9. So what's that mean? That means that you put like, this is e to the negative 9, right? So that means you have 9 0 in front of it. So the probabilities is 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 1, 3. Okay, so as you can see, the probability to have, if this person really is unrelated, so the chance for this person to get a 17 match is extremely small, right? So it's almost 0, 0. It's almost 0 chance we'll get the 17 match, but it matched. So what's that mean? That means the chance for this person to be the father is super high. So that's why we said, yes, I think probably this is the father of the person who tests, right? Because the chance for a random person to happen is extremely low. And now it happened. That means this person must not be the random. So the same things here. This is the same concept, right? Like in the criminal test, right? So right now we do a lot of DNA tests. So if we find the DNA match, then we will say this person probably, is the suspect, right? So we convict a lot of people based on the DNA test, or based on the, the match, the DNA matches here. The reason why it's the same, for two people, if this person is not the murderer, for two people have a matching DNA, it's so small. It's the 1 in a million or 10 million. And now you find a match. So probably this person did commit the crimes here, right? So this is the very interesting province. So that's why I want to talk about that. Okay, let's take a look at the number 15 here. Number 15. Okay, so this is number 15. So the number 15 here is I want to find the expected value. So this one is pretty simple, right? So we just, this is a Z, this is a PZ, and then this is a 9, 12, to the 21s, right? And then they have the different probabilities here, 0.14, and to the 0.07. So based on the section 8.5, we know the expected value, the way we define the expected value is you just use the numbers times the probabilities, right? So you just use each number times the probability, then add them together. So will be the 9 times 0.14 plus 12 times the 0.23, and then plus the 21 times the 0.07, right? Okay. Okay, so after you put this into the calculator, and we get the values here is 14.34. Okay. So that's what we call this expected value. So this is extremely kind of the simple and very mechanical here. Okay. So now let's take a look at number 16 here. Number 16 is interesting the problem also. They said an elevator have 7 passengers, and this elevator stop at 13 different floors here. It is equally likely that any person will get off any of those 13 floors. That means that any person can just randomly get off this 13th floor. And what is the, so part A is here, asks you, all the 7 passengers will get off at the same floor here. Okay, so all these 7 passengers will get off at the same floor, right? So what's that mean? That means you choose one floor, right? So then the chance for this ones here will get off is the 1/13 here. Okay, so let's take a look. So I have 7 passengers here, right? So they all get off at the same floor. Think about it, right? So for the first passengers, for example, you can choose any floor I want to get off, right? So I can choose any floor I want to get off. So the chance for the probability for the first passenger is 1. And then now, as soon as the first passenger choose it, then the second passenger has no choice. So has to be 1/13. Has to be 1/13, right? So has to be 1/13, has to be 1/13, has to be 1/13, has to be 1/13. So the overall here will be 13 to the 6th, 1/13 over the 6th power. The reason why is here, think about the total sample space here, right? So talk about here the total sample space. Remember, the total sample space, each passenger can choose any 13 floor. So that means the total sample space is 13 to the 7, correct? So the total sample space is 13 to the 7. And then now, you know, like they said, they get off at the same floor. So there are 13 same floor. So the events here, they have 13 floors they can choose. So that's why the probabilities here will be the same floor, right? So they can choose, say, I want to get out of the first floor, second floor. So you have 13 different choices for different floor. So that's why it's 13 to the 7. That's why the answer is 13 to the 6, right? So that's what is the 13 to the 6. Or you can use the way I outlined here, said, hey, the first person is 100%. You can choose any floor you have. After you choose that, then all the other, they only have a choice for that floor. So you will get the what? You will get the same answers here, right? Okay. Now let's take a look at part B here. The part B, they say, at least 2 passengers at the same floor. Okay, so this is come to this again. So at least 2 passengers here. So we know that at least, right? So we said we want to find at least 2 get on the same floor. That would be very difficult. Then we have like 2 people, 3 people, 4 people. Then we need to talk about all the 7. So then I can say here I use 1 minus, right? So I will say 1 minus the probability no one at the same floor. Or other way you can say is the probability they are all in different floor. Right? So that's what we say. Okay, they are all in different floor. Okay, so what that means here, let me say I do 1 minus, right? So my total sample space is everybody have 7 different ways. Everybody have a 13 different ways. So the sample space is 13 over 7. So now out of this 13th floor, I need to take a 7th floor because no one get on the same floor. So that means that everybody need to get out at one specific floor. And so that's why I have a P, because there are 13 different people, right? So I have the P, the 13 to the 7. Okay? So that's if you calculate it, you put it into your calculator, I get this is 0.137A. So the answer is here. This is 0.8622. All right. So now, right, so this is another place when you see at least, right? So you will use the no one at the same floor to make your calculations a lot easier. Okay, for the C's here, all the 7 passengers will get off at the even floor. Okay, so all the 7 passengers get off at the even floor. That means we have 6 even floors, right? Total, we have 6 even floor. We have 2, 4, 6, 8, 10, and 12. So they don't have to be on the same floor. As long as they are on an even floor, that'd be fine. So let's take a look at what is these probabilities here. This is the probability I'm getting on the even floors here, right? So the even floor, the sample space is here still is 13 over 7. Okay, so now every person right now, they have 6 floors to choose because 6 even floor. So I will have 6 for first passenger, 6 for the second passenger, 6 for the third one, 6 for the fifth one, 6 for the, right? So basically I have 6 to the 7 power to the 13 to the 7 powers here. So let's see the 6 for the 13 to the 7 power. Well, it's pretty small here, right? So that if you put it into the calculator, it will give you something like, let's see here, 6, let me see, 6 divided by 13 and to the 7 power. Okay, so it will give you 0.0046. So it's a very small probability they are all going to land at the same floors here, right? Okay, so let's see it for the chapter 3. chapter 3, the exam number 3 review. We did it in full video, and I hope this help you to study to prepare for the test. So make sure you review the videos, and the best way to prepare the exam number 3, it will be, you review the videos, and then you will redo the whole exam number 3 to see you be able to reproduce the same answer. If you can reproduce the same answer, that means you understand it, and you'll be able to do very good on the test. See here. All right. So that's it for the exam number 3, and study hard and get a good grade on it. All right. Okay. So I'll talk to you later.